The true nature of the universe is still one of our greatest unsolved mysteries. Yes, we understand more about the cosmos today than we ever have before, but we're still a long way away from being able to confidently claim that we know it all. There are huge portions of mass and energy that we're entirely confused by. There's a completely unknown and unobserved realm beyond the boundaries of light and physics. There are theories to suggest that even the most fundamental laws of our reality could be totally wrong. In this video, we'll begin by revealing the true scale of the universe as we currently understand it. Then, we'll shrink all of that down to ask whether everything there ever was could also exist inside just a single atom. And then finally, we'll dive into two other alternative models, both of which could have incomparably profound implications. This is Unveiled, and today we're taking a closer look at the different types of universes you should know about.
Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more thought-provoking content.
The universe is big, that much is certain. But it's easy to lose perspective of the objects and distances at work when they reach a certain size because there's really nothing to compare them to. And yet, for a long time now, humanity has been trying to, in some way, measure its reality. The first hurdle in measuring the universe is the measurements themselves. Determining the size of anything in outer space is difficult because there are so many metrics in play. You could measure the mass of something, the volume, the diameter, and each would give different results. Black holes, for example, are massive, but usually don't have large diameters relative to that mass. The supermassive black hole at the center of the Milky Way, Sagittarius A star, has a diameter around 30 to 40 times that of our Sun, which is big, but is also much smaller than some larger stars. Stars, by contrast, can have much less mass but still spread across a vast area, making them appear far larger. For this video, we're primarily working from the diameters of celestial objects as the best metric to determine their size. Planet Earth is the largest of the 4 inner planets in our solar system, though its diameter is only around 400 miles more than Venus's, which is sometimes called Earth's evil twin. Mars and Mercury are both much smaller, with Mercury being only twice Pluto, keeping in mind that Pluto's small size was one of the reasons that it was recategorized as a dwarf planet in 2006. Mars is 4,212 miles across, more than 3,700 miles smaller than Earth. But the Moon can actually hold its own here, being nearly 2,200 miles in diameter and therefore also larger than Pluto. But bizarrely, just the area taken up by the Pacific Ocean on Earth is still wide enough that the entire Moon could comfortably fit inside it. In terms of distances, the Moon is obviously the closest thing to us as well, but even it is 238,855 miles away. If the Earth were the size of a tennis ball, the Moon would sit roughly 7 feet away from it. The biggest planets in our solar system are the gas giants, and the biggest by far is Jupiter, which has a diameter of almost 87,000 miles, meaning Earth could fit inside it more than 1,300 times over. While the gas giants are huge, however, they also have very low densities, leading to the popular, though not exactly accurate assertion that if you had a body of water vast enough to hold Saturn, it could float. Really though, it's not uncommon for gaseous planets to balloon to such incredible sizes. More interesting are exceptionally large rocky worlds. Leading candidates as the largest known planets of this type include Kepler-10c, discovered in 2011 with 17 times more mass than Earth, and the catchily named BD plus 20594b, discovered in 2016 and thought to have a diameter more than double Earth's. Places like these are so big that they're officially classified as mega-Earths. But planets certainly aren't the biggest objects in the universe, not by a long shot. Stars are generally the largest singular objects. Our Sun is by far the largest thing in the solar system, but it's still not that big compared to others. The largest star we've ever found is UY Scuti, which boasts a diameter 1,700 times larger than the Sun's, despite being only 30 times more massive. The brightest star in our sky, apart from the Sun obviously, is Sirius, otherwise known as the Dog Star. The heaviest star is neither UY Scuti or Sirius though. It's a blue dwarf currently christened R136A1, which has 315 times the mass of the Sun. But let's zoom out further. Galaxies, made up of billions and billions of stars and planets combined, are among the biggest structures in the universe. Our own, the Milky Way, is thought to be an average-sized galaxy with an estimated diameter of at least 100,000 light-years. So far, we've only found a few thousand star systems in the Milky Way, but scientists predict that there could be billions more that we've yet to locate. And that's just in our galaxy alone. Working mostly with data from the Hubble telescope, astronomers have estimated that there are between 100 and 200 billion galaxies in the observable universe. The smallest of those are thought to be just 3,000 light-years across, while the largest are over 300,000 light-years across. The closest other galaxy to us is Andromeda, which is over 2.5 million light-years away. The really interesting part? In roughly 4.5 billion years, when the Earth is twice as old as it is now, Andromeda and the Milky Way are set to collide and blend into one giant galaxy, something which some scientists are already calling Milkdromeda. In reality, though, it's unlikely that we will ever see these distant planets, stars, or galaxies up close, simply because of the unfathomably huge distances between anything in outer space. Humans haven't even been to another planet in the solar system yet, but the solar system is really quite small in the grand cosmic scheme of things, with a radius from the Sun of around 1.87 light-years, and a light-year equating to around 5.88 trillion miles. That means it takes nearly 2 years for even light to travel out of just our star system. In general, though, the solar system is too small to practically measure it in light-years. Instead, we use astronomical units, with 1 AU the equivalent to the average distance between the Earth and the Sun, roughly 93 million miles. The distance from the Sun to the outermost edge of the solar system is 100,000 AU, but the next closest star to us, Proxima Centauri, is more than double that distance at over 268,000 AU, or 4.2 light-years away. In 2015, the New Horizons probe reached Pluto after a journey of more than 9 years. Say we continued at that speed, we'd reach Proxima Centauri in around 55,000 years' time. At the highest estimates, modern humans have only been on Earth for 300,000 years, so we'd need 1/6 of the whole of human history to make just a one-way trip to just the closest star system to our own out of the billions of star systems in the entire universe. But what's even crazier is that all of these objects, the planets, moons, stars, and galaxies, are only what we can see in the observable universe. The true universe is so huge that the light from the Big Bang hasn't yet reached every corner of it, despite traveling for close to 14 billion years. According to a 2011 study conducted by a team at Oxford University, the universe could even be as much as 250 times bigger than what we can currently see. And finally, when you consider that only 5% of everything is all that we can see and comprehend, the rest being dark energy and dark matter, then the staggering entity we're dealing with truly makes itself known. Space is larger than we can possibly comprehend, but it's still getting bigger and bigger.
The observable universe is more than 90 billion light-years across. The unobservable universe is far bigger still. The cosmos as a whole is so large, it's almost impossible to comprehend. And yet, from some perspectives, and according to some theories, it could all be so small and insignificant. Current calculations suggest that the unobservable universe could be anywhere upwards of 20 trillion light-years in diameter, an incredible distance. But though upwards of 20 trillion light-years is enormous, most of it is probably empty. We can reasonably assume this because of what we know about the universe we can see, which is that it's uniform in every direction, but also that observable matter is scarce. To our eyes, most of everything is nothingness. Even so, it's not as though this observable matter just happens. It isn't simply a case of it just being there. Consult any physics textbook, and we know that matter is actually lots and lots of atoms, the tiny things that make up everything in existence. And atoms are so small that even our most powerful optical microscopes can't actually see them, meaning we have little idea what they actually look like beyond predicted scientific diagrams. Nevertheless, rigorous science has proven that atoms definitely do exist, and also that they themselves are made up of subatomic particles, including protons, neutrons, electrons, and quarks. Today we know, for example, that atoms are so small and numerous that the average adult human contains roughly 7 octillion of them. which is a 7 with 27 zeros after it. It's amazing then that there are some theories that every human, that everything and everywhere, that our entire observable and unobservable universe could actually be an atom in itself. One such idea is the one-electron universe theory, which says that what we understand to be electrons are actually all the product of just one particle. With that particle, that one single electron, infinitely traveling backwards and forwards through time so quickly that we perceive it to be many. So much so that it intricately renders and shapes our entire reality. Perhaps unsurprisingly, there isn't much by way of a solid backing in the scientific community for this particular theory. But it's a starting point, and there are other similar ideas with more support. The more mainstream variation is that while all of the atoms and electrons and properties of matter do exist as we understand them to, they all amount to the equivalent of an atom in another, much larger universe. With its roots in the multiverse theory, this is an idea that science fiction writers and filmmakers have regularly experimented with, that everything we know could fit onto the fingertips of something else, that our universe is but a speck of dust on some higher plane of existence. Or we can go the other way and look inwards to imagine that all of the atoms that make up our existence actually contain whole other existences inside them. It's a mind-bending concept that's again also built on the notion of infinity. Other than being the cornerstone of Buzz Lightyear's iconic catchphrase, infinity is, naturally, such an incredibly unendingly large idea to try to wrap our heads around. But here it could be understood to mean that regardless of how large our universe is, if we accept the multiverse theory, then another universe could be infinitely larger, making us, by comparison, from the vantage point of anything in that larger universe, subatomic. And when we look around, we see that the universe, as we generally understand it at least, already functions a little like this. All the minuscule subatomic particles go on to create bigger and bigger things, until we're dealing with the largest celestial objects and the most complex known organisms. Whether it's gigantic stars in a far-flung galaxy, soaring skyscrapers in a busy city, or just that sandwich you had for lunch today. It all uses the exact same building materials. So why stop with just the biggest things we know about? Why not zoom out and out and out until, yes, even the universe is just one part of something much bigger? Until we have a true theory of everything, a theory to marry quantum and classical physics and finally explain reality, this blurring between the micro and macro levels can't totally be dismissed. After all, according to the most popular theory on its creation, the universe itself started out as an infinitely dense and tiny singularity before it expanded into energy and life via the Big Bang. So at one time, everything we've ever known really was inconceivably small. Of course, the big difference here is that the initial Big Bang-inspired singularity, no matter how small it could have ever been, would have contained all of the stuff needed for the atoms we now know about. So we can't justifiably claim that the universe, even at this stage, actually was an atom. A singularity, yes. An atom, no. Perhaps we get closest to understanding the true scale of reality via string theory, one of the more prominent candidates for a theory of everything that we currently have. There are various models of it, but the general idea is that atoms aren't the spherical objects we tend to draw them as. Instead, they're string-like objects that vibrate. And it's the interactions between these vibrating strings that account for, well, everything. The laws of physics, how gravity works, quantum mechanics, the whole caboodle. String theory has encountered its fair share of problems, though, one of which being dark energy. The issue is that while normal observable matter, the stuff that string theory attempts to make sense of, makes up only 5% of the universe, a massive 68% of the universe is dark energy. And most string theory models can't explain that. More recently, though, there have been various attempts to incorporate dark energy into string theory. In late 2018, a team from Uppsala University in Sweden published details of a new variation of string theory, wherein our universe exists on the edge of a constantly expanding bubble. While most string theory proposals do suggest various higher dimensions than simply the 4 we currently know about, 3 spatial and 1 time, Here we find that everything we know is actually a fleck on the membrane of something far, far greater. So really, who knows what's happening inside the bubble or away from the bubble's edge, or how many dimensions these unknowns could account for? But the infiltration of dark energy into our universe from the wider bubble universe could, at least according to the theory, finally make sense. Irrespective of what it means for dark energy, though, it's another version of reality which potentially pits us as an infinitesimally tiny part of something much, much bigger. Something far greater, perhaps, than we could ever even hope to understand. In this instance, with human beings serving as just one tiny part in one tiny universe on the edge of a bubble that in itself could be one part of something even bigger, we're basically a proton or an electron or a quark in the grand scheme of things. If a proton could think, would we expect it to know that it accounts for a tiny bit of a sports car? Or an electron to understand that it represents a minuscule fraction of a single blade of grass? Obviously not, but we'd now be in that same mind-boggling position. Ultimately, if the universe really were structured like this, then it would clearly shatter almost everything we thought or even suspected we knew. In fact, we would be so deeply wrong about science on essentially every level that human knowledge might never recover from the revelation. It would be existential crisis from here on out, and a race to try and figure out some all-new extra-dimensional laws of reality. It's lucky then that this is just a thought experiment, a fun way to think about things and to appreciate our place in the cosmos. Sure, our knowledge might prove to be limited, and our perspective might be off, but even if all of this really was subatomic insignificance from the point of view of something else, then why should it really matter? We're here now, so let's enjoy our atom while we can.
So that's the scale of the universe covered, and the hypothetical scaling down of it so that literally everything exists within a mere atom from a higher perspective. Now, though, settle in for a couple more speculative ideas, although both are gaining a greater and greater following in recent times.
What if everything you know, from the people you love to the activities you do, and even your very own body and mind, is part of an expansive and immersive illusion to fool you and everyone else about reality? As we've found out in previous videos, scientists are now increasingly convinced that there's more to this universe than just this universe. And the consideration of multiple universes in one way or another is now par for the course for most theoretical thinkers. But meanwhile, humanity has witnessed so many great advances in the field of computing over the last century or so, enabling us to create massive and simulated worlds of our own in the name of entertainment, gaming, virtual reality, and AI. Could it ever be possible, then, that we aren't just building these worlds, but are actually living in one ourselves? The concept of a simulated reality has perhaps a surprisingly long history. It was first seriously thought on by French philosopher René Descartes in the 17th century. Among many things, Descartes imagined an evil demon figure using a great and ominous power to deceive unsuspecting humans by projecting a kind of unreal reality. A modern take on Descartes' evil demon argument has since been formulated by the Oxford philosopher Nick Bostrom in his 2003 paper on what's now known as the simulation hypothesis. The premise behind Bostrom's hypothesis is that all of reality could be an artificial sim most likely run by an advanced supercomputer or civilization. In pop culture, the 1999 movie The Matrix offers perhaps the most famous use of this idea, where humans live in an artificially constructed world run by highly advanced machines. But putting wild blockbuster imagination aside, could this really be what's happening to us right now? Well, it depends. Any civilization capable of running such a sim must first have reached a level of technological advancement enabling them to create one. Remember, we're talking total control here over everything from the smallest atom to the largest galaxy. And to apply all that to the multiverse model, the sim controllers would need to have built a kind of endless loop into their system too, to generate all of the infinite possibilities of multiple realities. Such a civilization would also need to have generated a convincing means of simulated consciousness, however, to match natural, genuine consciousness, so that inhabitants of the sim, in this case us, remain totally unsuspecting. The idea entirely depends, then, on whether such an advanced and capable civilization could ever exist. But a simulated multiverse has certainly been theorized before, including as part of the theoretical physicist Brian Greene's 9 multiverse types. So what would a sim multiverse actually mean? Well, the advanced civilizations needed to run them would firstly require access to enormous amounts of computational resources in their world, the real world. Some possibilities for obtaining this include the building of a civilization that's based on nanomachines spreading out forever, or on giant megastructures like Matryoshka machines where the entire energy output of a star is harvested to power a stellar computer. Pool all of that power together into one single spectacular generator machine, and a custom-built multiverse might be possible, in theory. Although, of course, that multiverse could never truly encapsulate all of reality, seeing as the controllers themselves would exist outside of it. It places a different slant on the overall idea, however, wherein humanity, the universe, and all of reality as we know it exists as just one simulation among potentially millions of others, much as with various simulator video games in our world. Everything we know and can ever know could then exist on some disk somewhere, or as part of some kind of expansion pack, which is a pretty frightening thought, especially if that disk were ever to get lost or scratched or snapped or thrown away. It's a somewhat outlandish way to view life, certainly. But thanks in part to our own rapid technological advancements in the past few decades, support for the simulation hypothesis in general has mounted in recent years, including famously from Neil deGrasse Tyson and Elon Musk. Physicists generally interpret the simulation hypothesis by viewing the universe as a flow of information as opposed to energy. This shift was particularly pushed by a one John Wheeler, a pioneer of quantum computing in the late 1970s. In almost all models, though, reality, true reality, needs to exist as though on another higher level, a different dimension or a different plane of existence. It's only from there that this sim, our world, could possibly be born. Although there are various down-the-rabbit-hole theories to propose that actually a sim might be possible on our level too, so that we end up with simulated realities inside simulated realities and on forever. Clearly, if this is true, it's pretty advanced stuff. Down here, though, on the ground, so to speak, we know that there are endless mysteries and inconsistencies about our reality that could quite simply be explained away if we just blamed it on the controllers of the sim. The many wonders of quantum mechanics especially would begin to look different from our point of view. For example, in one version of the multiverse, all moments of choice or chance, even at the quantum level, are actually the genesis for another new timeline and therefore another world. This is already an eerie thought, but in a simulated hypothesis it begins to take on a different meaning. Now those quantum splits are controlled by whatever runs the sim, in a similar way as to how we press buttons to make even tiny choices for characters in video game sims today. Perhaps more so than with any other multiverse model, the simulated multiverse certainly does require some sort of higher power, you might call it God, to make it work. If we were to accept the simulated multiverse, then, how should we go about our lives with that knowledge? One suggestion might be to strive for greater heights in this world as we understand it, to better our position, and therefore to lessen the likelihood of ourselves getting turned off. It's an idea that's been mused by, amongst others, the economist Robin Hanson, but it's an approach that could also inevitably lead to a selfish existence for all, where our personal wants and goals would trump everything else, and perhaps that particular reality wouldn't function all that well for all that long before chaos took hold. Another aspect to consider is, should we even be trying to prove a simulated reality at all, if indeed that is what we're living in? According to some interpretations of the model, this could spell instant trouble. The idea being that if we were to somehow know the sim was true, then that act of knowing could either end our simulated existence or crash the simulation itself. In other words, we may have effectively completed the game, or corrupted it, which in either case would result in game over. But finally, to be clear, the simulated multiverse is still an idea only. There is very little beyond our own imaginative theories that we can use to support the view as a true way of the world. The simulation hypothesis in general isn't without its fair share of skeptics or detractors either. For one, the Harvard physicist Lisa Randall has continually rallied against the idea. One argument against the simulation might also boil down to the notion that humans are inherently motivated by self-interest. But rather than this being a strategy to survive a simulated reality, we could ask why a higher species would bother simulating us in the first place. If you had all that power, would you remake humans in the 21st century? Or would you do something else? There have been various studies, too, to show how completely and extremely difficult it would be to simulate even a tiny part of this reality. Of course, on the flip side of that, if the simulated multiverse were true, then it probably would appear impossible from our lowly perspective and position. Ultimately, then, it's a question of what we're capable of and what anything is capable of. As we move through the 21st century, our computing powers are predicted to increase so that within just one generation's time, humans will look back at today and wonder how the heck we ever got anything done. But even so, there are giant strides between that and becoming a next-level civilization with the multiverse in the palm of its hand. If no civilization or group has ever made that jump, then no, we aren't living in a simulated multiverse. But if such a power is ever achievable, then in a universe or multiverse with infinite possibilities, perhaps there is something out there that's guiding our every move. Maybe.
Only 500 years ago, it was widely accepted that the Earth was at the center of the universe. Then came Copernicus, Galileo, and the heliocentric model of the solar system, with the sun in the middle, marking a paradigm shift in how we understood our own importance in the cosmos. But what would change if we today discovered a completely different universe alongside our own? Theories on multiple universes aren't a new phenomenon. They've been explored within the highest circles of science and philosophy, and they're a popular science fiction and fantasy trope seen everywhere from Star Trek to Stranger Things. In fact, there's at least 5 major academic theories as to how parallel universes could be possible, and a 2016 study even argued that a mirror universe genuinely exists where time moves backwards instead of forwards, the idea being that such a place makes just as much mathematical sense as our own universe does. In some ways, the question is an offshoot from the theory of infinite universes, which says that space-time is endless and is therefore home to all possible combinations of atoms. According to this proposal, there are infinite variations of our own universe, with people just like you living within them, but with minor differences each time. If true, then logic says there's a universe out there which has already discovered its mirror image twin, where everything's the same, but backwards. So what if that universe was our own? And are we already partway to proving it? A 2017 study raised the possibility of at least other universes by focusing on a cold spot in space. This spot is a large area that's much cooler than the rest of the surrounding universe and doesn't truly fit within our current cosmological models. So the theory goes the cold spot could have been created by our own universe colliding with another in the past. Elsewhere, leading astrophysicists such as Neil deGrasse Tyson, Brian Greene, and Michio Kaku have all proposed that we could identify a mirror universe with new technology or a better understanding of dimensions, bearing in mind that string theory, currently one of the leading candidates as a theory for everything, points to there being at least 10 dimensions. So say we actually discover a mirror universe that's filled with mirror images of ourselves. What would the repercussions be? As imagined in things like DC Comics and Star Trek, the mirror people could have a twisted sense of morality, a completely different sense of right and wrong, and hopes, dreams, and ambitions totally at odds with our own. On the other hand, they may have avoided making various mistakes that we ourselves have made. Perhaps our own global concerns like climate change and nuclear war aren't as prevalent in the mirror universe, for instance. Regardless of the status and condition of such a place, the knowledge that it even exists could prove a huge mental challenge for the majority of us. Many would outright refuse to believe it, even with proof, while those who did accept it could panic at the news, now uncomfortably aware of our, and even our own universe's apparent insignificance. As a widespread existential crisis sets in, depression cases could soar. Some might try to isolate themselves within their newly alien reality, and others could see the revelation of their own alter ego as granting them free rein to behave in whichever way they feel like. Because what would it matter anyway? At the same time, we'd see others excited, amazed, and motivated by such a seismic and fundamental change to their lives. They'd no doubt be eager to study and learn more about the still mysterious mirror universe, in a bid to somehow contact their alternative selves, making cross-universe connections between us and them. Religions could well form around these new versions of ourselves, perhaps calling them gods or higher beings. But what about religions that already exist? For some, the confirmation of another universe would strengthen their belief in one supreme being. For others, it would shatter it. We could well adopt the ancient Greek atomist way of thinking, which saw philosophers argue that what we now call the multiverse disproves the need for any god. According to them, the emergence of other universes would explain how everything works so perfectly in our own. Instead of a creator god, unlimited replicas of our own world show that our specific experience of life is simply inevitable. That's not to say that a parallel realm would instantly dismantle all established religious beliefs, though. Perhaps Christianity would see our mirror selves as having sinned and fallen from grace, or even vice versa, where in fact we are the ones who have failed. Hinduism teaches that we reincarnate on Earth based on our actions in previous lives. So from that perspective, an exact mirror image of ourselves could be part of our individual learning process and growth, on the way to eventual transcendence. The philosophical implications would be similarly self-reflective. Mirror universes and alter egos would unforgivingly show that we're extremely insignificant and small, even more so than we currently believe. It'd mean that we're not so unique after all, but are perhaps just one of many mass-produced versions of ourselves, all existing along a spectrum between the us in this world and our direct opposite in the mirror world. In which case, who's to say that we, as in the version of us alive as we currently comprehend it, are the best version of our own self? The moral foundations theory identifies specific moral belief systems and explains how all humans have an underlying moral compass that's similar to most other people's. As per the theory, we don't generally like to cause harm to others, and we strive for fairness. But our mirror selves would harbor the exact opposite ideals, and if mirror versions really does imply an infinite number of versions between us and them, then that moral code is constantly tweaked from one universe to the next. Finally, because of the almost unfathomable link we'd share with the mirror universe, it could help us make sense of other largely unexplained phenomena. There are various theories on why we experience déjà vu, for example, but we've yet to identify a definite reason. Some believe that it's the result of remembering or experiencing another life, so a confirmed mirror world could then explain déjà vu as simply a brief glimpse into that alternate space. Similarly, we'd have an all-new take on the deep-rooted meanings behind our dreams, with suggestions that they could signal a shared consciousness with our mirror selves while we sleep. The discovery of a mirror universe would mean much more than plain speculation, though. It'd impact every choice we make, every risk we take, and every belief we hold, because we'd know that somewhere there's someone doing the exact opposite. When we say yes, they say no. When we turn left, they turn right. When we breathe in, they breathe out. And just to increase the existential weirdness, perhaps they'd be acutely aware of us as well. Life would be a fundamentally different experience.
So what do you think? How does contemplating the universe make you feel? And do you believe that, really, the cosmos is quite different to how conventional science explains it? Let us know your thoughts and ideas in the comments. For now, while it's true that the overriding nature of our reality does remain somewhat shrouded in mystery, it's also true that there's never been a time before when humankind has been so determined to discover the answers it needs. And as you look up to the stars at night, that's a pretty exciting realization.
What do you think? Is there anything we missed? Let us know in the comments. Check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.